Good day, everyone. So today I'm going to share with you another discussion video about the volume of a solid of revolution. We will move on to the example number 3. So for this example, it's just similar to your previous example, which is an example 2, but we will rotate the area bounded by the curve, the y-axis, and the line y is equals to 1 about x is equals to 4. So we need to find the volume formed by revolving the area bounded by the curve x squared is equal to 4 quantity x minus y, quantity and the y-axis, and the line y is equals to 1 about x is equals to 4. So I think we already solved for the important details that we should have about the enclosed region. So we already solved for the vertex. We solve for the intersection points, which are the 2, 1, and 0, 0, and the vertex is 2, 1. Now, this is the time to plot it. Take note that we will revolve our area bounded by the curve and y-axis and the line y equals to 1 about x is equals to 4. Now, we already have the details about our graph. Now, this is the time to draw it in our Cartesian plane. Imagine that I draw it perfectly. So, in this example, our enclosed region will be rotated about x equals to 4. So, it will rotate here. So, we are given with the parabola which is facing downward at vertex 2, 1. So imagine that this part here is 1. So this is the vertex. So we need to get the area enclosed by the parabola y equals to 1. So this is the vertex y equals to 1 here. Then our curve at x is 0, which is the y-axis, y is 0. So our parabola is facing downward, so it's like this. So this is the bounded region, the y-axis, which is x equals to 0, and then the curve and the line y equals to 1. So this is the bounded region by the given parameters we have. So this region here or area here will be rotated about x equals to 4. So here, to get the volume, we can make use of the cylindrical shell method or the circular ring method. But for this given example, it's very okay, or it's better to use the cylindrical shell method. Why? Because it's easier for us to integrate it later on. You could see it. So in cylindrical shell method, we need to know the axis of rotation, so which is the x is equals to 4. So in cylindrical shell method, you should use vertical strip here because our strip must be parallel to the axis of rotation. So x equals to 4, that's line x equals to 4, which is in it is a vertical line, so we need to make use of the vertical strip as well, so that we could have a parallel um, stripping to the axis of rotation. So this is our dx. So in cylindrical shell method also, we need to define our length. So the distance from your y-axis to the strip is x. So the distance from here to the axis of rotation is 4, because this is 4 minus x, we could get the distance of this. Now, we also need to know the um, the distance from the top part of the curve down to the bottom part of the curve. So we need to know the distance of this, which the distance of this is, if this is 1 here, therefore this part here, the bottom part of the curve, is y. So the bottom part of the curve to the x-axis is y, right? So therefore, this one here is y minus, 1 minus y, right? So in cylindrical shell method, we need to know the radius and the length, right? So now, our working equation is volume is equal to 2 pi, integration of length times height times the change of um, height, right? Length times height times the change of height from A to B. So we have to put it in our given Cartesian plane here. V is equal to 2 pi times integration of integration from A to B. Our length here, the length here is this one. So y minus 1 minus y times our height. The height here, which is from here to here, which is 4 minus x times dh. So we could form like a cylinder here. So it means that this part, if you will try to imagine that this is the radius and this is the height. So with that, we have our working equation now. So volume is equal to 2 pi integration of 1 times your y. Your y is the y value of your parabola, which is, as you can see here, this is y. It's from the x-axis to your bottom part of the curve, and the bottom part of the curve, the bottom part of your strip is the curve. So you have y. So which is y is equal to quantity minus or negative x squared all over 4 plus x, right? That's the value of y, quantity, times 4 minus x. Simply put it as x, dx. From your lower limit, which is your a, which is 0, we are making use of these vertical strip. So from 0 to this part of your strip, which is, this is vertex 2, 1, so to 2. So 0 to 2. So you have volume 2 pi. Let's try to expand the expression here. So from 0 to 2, this is equal to 1. We have plus x squared all over 4 minus x times 4 minus x quantity dx. Let's try to expand it. We have volume 2 pi integration from 0 to 2. This is equal to 4 plus x squared x squared minus 4x minus x cubed all over 4 plus x squared quantity dx. We have volume 2 pi. This is equal to, you could integrate it immediately. So this is 4x plus x cubed all over 3 minus, we could add up x squared, so you have 2 here. So x squared plus x squared, that's 2x, and get the Integration of this 2x squared, that's 2x cubed all over 3, minus negative 4x minus x, that's negative 5x. Then get the integration, that's 5x squared all over 2, minus x cubed plus 1, that's 4 all over 4 times 4, that's 16. Right? From 0 to 2. So we will have to substitute the values of your upper limit and your lower limit to the equation. You have 2 pi times quantity 4 times 2 plus 2 times 2 raised to 3 all over 3 minus 5 times 2 raised to 2 all over 2 minus 2 raised to the fourth power minus all over 16, sorry, all over 16. Because we have a lower boundary which is 0, just simply put 0 because you already have values of x here. So all of it becomes 0. So our volume for this given is equivalent to 14 pi all over 3. That's 3, not a heart. 14 pi all over 3 cubic units. So this is now our final answer.